Introduction to Programming, Workstation and Behavior-Driven Development. Programming is simple, friendly, rewarding, fun, and relaxing. It will set you free from poverty and drive you to make the world a better place. People who think it's funny to say that are the people that brainlessly walked into some high-stress meat grinder and now hate life. As with everything else, if you are forced to learn programming and forced to program under a threat of bankruptcy and poverty, it will all seem awful. One of our first responsibilities in life is to push toxic people and environments away. There is nothing negative in the world of programming. It is an art like everything else worth the while. Just like it is not perfect to sit down to learning how to paint with a cup of tea or coffee as paint, which would be beautiful, but it's not perfect, and paper that is not really all that good for watercolors, and a brush that could be better, you have to assemble your programming environment with a kind of love, and you will need a mascot to keep you company and for duck debugging. It does not need to be a duck. I have a fuggler, the red suspicious fox, and I call him Bobo or Boobs for short, after an angry dog I like. Your programming computer should be the 8GB Raspberry Pi 4 Model B. Maybe get a Raspberry Pi 400 as your secondary computer just for playing around. You will need a monitor and a keyboard and a mouse and possibly an external drive. I would recommend that you get a simple monitor. The Raspberry Pi supports 2 4K monitors, but all of that is very overpriced. Maybe 2 cheap monitors that run about $270. Consider getting a mechanical keyboard, perhaps EpoMaker Acco or An Pro. And your programming language should be ES 2021 or whatever year you are in. This is the evolving JavaScript language. I know many programming languages, but I don't have time to use them all and I keep forgetting stuff. There's no point in learning a language that you will not use 5 years from now. You have to learn the language of the web. It works in the browser, in application frameworks like Electron or P5.js or Tone.js, and on the server and on your Raspberry Pi. You will need to install Node.js and search internet videos for Node.js tutorials. Of course, above all, you need a reason, something you are or can be passionate about. And it has to be something that many people can work on at the same time. So something inspired by WikiWiki, the program that inspired MediaWiki, which runs Wikipedia. See, the point is to allow strangers to come in and contribute to your program by just clicking edit, without signing up for anything, without even giving their email. Most recently, I have been greatly inspired by the SCP Wiki. Even though it's not a computer program, though it is a kind of a game of a kind. Just this morning, I was reading about SCP-087 and I didn't finish. And to hell with all that! I actually had to turn my lights up. See, multiple people are contributing to a single story, almost a game, and that is the platform that you must start with, because it will make your program come to life. But you will have to program your own WikiWiki and allow people to enter code into it via Code Mirror. I can't tell you what your project should be about, not really, but it should contain your own take on BDD, so that you can focus on sketching and let others code the complicated stuff for you, at least at first. Behavior-driven development, or BDD for short, describes computer programs in plain English, leaving it to programmers to fill in what is broken. BDD is very simple, but I am yet to find a simple explanation. BDD is about writing stories about your program. These stories describe what is going on, what is about to happen, and what should be the result of that action. If what happened does not create the expected result, then you will know that part of your program is either broken or unfinished. Let us begin programming a simple game where a squirrel eats a peanut. First, we describe the world. There's a peanut on the ground, a tree, a squirrel in the tree, and she is really hungry. In the world of computers, you have 4 objects here: peanut, ground, tree, and squirrel. The squirrel has a property of hungry. Since our story seems to hint on a squirrel that can have multiple levels of hungry, rather than a true or false or hungry not hungry, let us make the property a percent. Since we don't want to do any special math, we will express percent as a fraction between 0 and 1, where 0 is not quite hungry but may eat something, and 1 is really hungry and is about to pass out for a little while. Let's tidy up the place a bit and create a world for our objects, the main container. So now, world contains ground, ground contains peanut, and a tree, and tree contains squirrel, with a property of hungry. In computer world, there are primitive variables like number, or fraction, or letter, or word, but also complex variables like objects that can contain a primitive like hungry, or list like an inventory that may or may not include a peanut. Though it is tempting to think of everything as a variable, don't do that too much. An object is a perfect and precise thing. Though it can contain a list, don't think of it as a single unit where you set it and forget it. In the world of databases, in order to allow billions of records and fast search queries, you really want to keep objects and lists separate and load their data separately and treat each with a kind of respect. The kind of thinking that schools teach, where you say, I created a squirrel with a number expressing hunger and an inventory list that may hold a peanut, is too simple and won't translate well to databases. Just think of it as an object with properties that also has a list called inventory. Not object with properties where one of the properties is a list. Be respectful and mindful of data structures. Remember them and keep them loosely coupled. If everything becomes too tightly bound, you will cut yourself off from easily speaking to simple databases. Now that we have a world, we know that the squirrel isn't doing anything. It is just really hungry. It is like a world without anything going on. Everything is frozen in time. So now we have to describe some action, something that will cause a change. If we were just writing a normal story in an essay, we would first describe the world and then what was going on in that world. Same thing is happening here, but the two things, story context and action event, must be kept even more separate. And we have to be serious about this, because somewhere down the road we may add a new action event that will reuse the story so that we can test something other than the squirrel. The story context will stay the same. We will only add an action event, or 100 of them. If we keep our BDD nice and tidy, if we are keeping context separate from action, it will all be very easy to understand. So in this action event, we just make the squirrel simply notice the peanut, jump down from the tree, and put it in her little cheek. And that's it. But this is a lot, because now the tree no longer contains the squirrel, the ground no longer contains the peanut, and all kinds of things have changed. The universe has shifted. So now we add the outcome test. This is what BDD and all this crazy story writing is about. We now describe the state of things in the stuck-a-peanut-in-her-cheek world. And if the program does not behave the same way as the outcome, we know that it is either unfinished or broken and can send a programmer in here to test code. Our test of outcome must at least describe that the peanut and squirrel have moved, that the squirrel is on the ground and the peanut, well, it is in the squirrel. We don't care if cheeks or stomach, we don't care if the peanut is whole or crunched up. The little tiny details are unimportant to our game. Nobody cares to test these details. Nobody cares to pay programmers to test them. Think of it as doing scientific research and trying to figure out what the structure of DNA is, and then coming across another molecule, one that is not the point of your research. You just don't pay attention to it. To give some structure to what is basically text, BDD developers came up with a kind of a language, they had to, that sort of everyone kind of agreed on using. They did it to be really precise about what is what. So the story description starts with the word given. The action description starts with the word when. And the outcome description starts with the word then. So, given, when, then. Given this kind of a world, when a squirrel jumps down to the ground and eats a peanut, then expect the peanut to be in the squirrel. Given this type of a world, when this thing happens, then this stuff should be true. When other programmers read your BDD, they will be familiar with the given, when, then method of story writing and will continue playing along so that now you are going to be able to read any new tests they add. Let us describe our squirrel story in BDD syntax now. Given, the world has a squirrel in a tree, and the squirrel is really hungry, and there is a peanut on the ground. When the squirrel notices the peanut, then the squirrel leaves the tree and gets on the ground and puts the peanut in her cheek. When the squirrel eats the peanut, then the squirrel is no longer really hungry. Note how I added a second when, where the squirrel actually ate the peanut. I actually reused the story context. I just added a new action and a test. Also note that I chain things with the word and. That's part of the BDD language. As in, the squirrel leaves the tree and gets on the ground and puts the peanut in her cheek. This syntax exists for the purpose of keeping BDD programs simple. Dealing with English text is a difficult problem, but if we just patiently take that one extra step and use given, when, then, and, it makes a world of difference and greatly simplifies the BDD system. I shouldn't mention this because I didn't want to mix anything up, but personally, I kind of think of this syntax as a subset of English, one that is just used amongst us, the programmers. Yes, you are a programmer now. And now you may wish to ask, well, how the heck do I run this thing? Is there a program? And how will it know about squirrels? You will have to write 2 programs to run the squirrel world. First is the game that we are describing, and second is a testing framework where we will import the game and pretend we are a player while running the tests we just created. The types of games that deal with squirrels, or virtual worlds for that matter, are called MUD, as in M-U-D. It's short for multi-user dungeon, or multi-user dungeon object-oriented. Writing a MUD is a fun way to learn programming. You can probably do it in 20 lines of code, but you may actually fall in love with programming mini worlds and grow them to 1,000,000 lines of code. If you are not into computer games, then you should know that a MUD can be used to generate poetry. For example, imagine that the world exists in a poet's mind. And when the game is executed for real, the squirrel will examine its environment while muttering something about leaves and trees, and then rhyme something poetic about peanuts, hunger, and how they are crunchy. Here is one such program called Limerick. It took no effort to create it. It was just a lot of fun. Another way to describe how poems can be created, imagine a 3D game, but get rid of the monitor. And instead of displaying graphics on the screen, you will need to use text-to-speech synthesis to speak what is going on into the user's headset. So now instead of displaying a 3D wall, you will say that there is a wall, and instead of showing the texture, you will describe what the texture is like. Once you write a tiny MUD, then you create a program called test and import your world as a little module and begin executing the BDD tests. You load up the story file we created and just parse, beginning with the first line. Given the world has a squirrel in a tree, you instruct your MUD to create a new world, create a tree object, create a squirrel object, and then add the squirrel to the tree. Now you just move on to the second line, and the squirrel is really hungry. So you set the hunger value of the squirrel object to 1, Or maybe energy value of the squirrel to 0.01, meaning that it's running out of energy and only food can restore it in context of this game. And continue on and on. When you develop your mud, you define plants, trees, animals, so this is really easy to just get them in there and just set them up for the purpose of the test or the storyline. The way you parse a line of text that you loaded from a file is kind of unusual in BDD systems. What you want to do is create a tiny program precisely named after that line. So if the line changes, the program becomes disassociated. It goes away. The easiest way to associate a program with given the world has a squirrel in a tree is just creating a function or a file named after the slugged version of the sentence. To make a slug is to lowercase everything and replace spaces and commas with single hyphens. Just simplify it. Another way is to use regular expressions. Ooh! JavaScript has named capture groups now, so regular expressions are much, much easier than they used to be. As you are learning programming, do what feels right for you. Learn by making mistakes. Personally, this would be where I would take a moment to grok regex once and for all. Regular expressions are used on the Unix command line as well, so you'd be learning something that is useful in other places too. There are plenty of regular expression visualization tools, so you can see how the matches are occurring. If you don't feel right about learning regex, don't do it. It's an acquired taste. I think a lot of people just Google regex, how do I match email address, and just go with the results until they start seeing patterns and finally take the plunge. In terms of how frequently you use regular expressions in programming, not often. Instead of matching something to recognize it, you really want to specify the type of thing it really is. When I write my video book, instead of going around trying to recognize YouTube URLs, I just strongly state type equals YouTube. And there is no question that the ID that follows is a video ID. But when you are dealing with something like parsing English and a BDD line of text, then regular expressions are worth the CPU cycles and the trouble. The thing that regular expressions are used for in BDD statements is fishing out variables. So when you see, and the squirrel is really hungry, the word really specifies how hungry the squirrel is. And not only can you extract a single value, but multiple throughout the sentence, and without making things too hard to read. In closing, once you take to a bunch of JavaScript and Node.js tutorials, you are going to need some interesting ideas. Writing your own wiki is a great idea until you are finished writing it. To make it useful, or even to make a business inspiration out of it, you have to make it do something interesting. And to make it fascinating, you have to open it to the world so that others can edit your program. It is up to you to figure out how to bless that alien code. Look at the way software on GitHub grows. When someone writes new code, it is sent to the program's owner as a request to merge. This way, everything is submitted in small, readable chunks and gets reviewed without much confusion. Creating a text game where thousands of people can edit the story and then enter the world and watch others solve the puzzles they created can be a fun little project. Something more advanced and more business-minded can be a wiki that uses Tone.js to create a clone of the leading digital audio workstation and then make music. It is really difficult to write large programs by yourself, but if you have thousands of contributors, some working for tips, for bounties, or big prizes, then a large program can be made pretty quickly. The issue of managing hundreds of thousands of tasks and thousands of developers becomes greatly simplified when you use something like BDD, especially BDD that has been finely tuned to your program. Programmers write programs for self-education and fun. But when it comes to large applications, learn from the success of the World Encyclopedia. It is very difficult to inspire you to a program that you may wish to create. I can't really help you with dreaming it up. But I can show you how to do it in such a way so that other programmers may join you for all the fun and some meaningful reward. Whatever it is you build it a page at a time. Combine WikiWiki with BDD, maybe MUD, and make the story more important than the code, as demonstrated by Literate Programming by Donald Knuth. Programming is just another form of art. Just learn at the pace that fits you best and in a sequence that matches what you already know, without anybody timing you or telling you what to learn, because that only makes it more difficult.